compute the derivatives of the given functions, and the first one we're given is f of r equals 13 to the r. So what kind of function is this? It's exponential, and so we're going to apply straight exponential rule, natural log of 13 times 13 to the r, the basic derivative rule for exponentials. We also talked about Leibniz notation, which has a d in the numerator and a d in the denominator. So f here is a function of r. If I were going to write this with Leibniz notation, it would be df over dr equals ln of 13 times 13 to the r. The important thing here is that whether you write it with Leibniz notation or prime notation, it's the same thing. Then we have g of s equals 8 squared. What kind of function is this? Constant. Why? Yep, there's no s in this case. Would be the variable we'd be looking for. So there's no unknown variables. It's just a number exactly. So g prime of s for a constant function is equal to 0. Now the last one is the tricky one, the trickiest one, as 10 to the t over 9. So if we look at 10 to the t over 9 to the t, when we first start out, this looks like a ratio or a quotient. But in this case, we actually don't need that. Because if you think about what 10 to the t and 9 to the t mean, there's an algebraic way to rewrite this. So 10 to the t is 10 times 10 times 10 times 10. And when I multiply this out, I get t copies of 10. This is t tens multiplied together. And then on the bottom, what do I have? 9 to the t is 9, 9. Let's see, that's t nines multiplied together. And I can think of this as 10 over 9 multiplied by itself t times. So 10 to the t over 9 to the t is the same thing as 10 over 9 raised to the. So now if I rewrite it that way, and I ask what's the derivative of 10 to the t 9, 10 over 9 raised to the t's power, d by dx of 10 over 9 raised to the t, natural log of 10 over 9 times 10 over 9 raised to the t. So this would be my final thing that I needed to type in.